So far, we've been basing our stoichiometric calculations on one of the reactants, how much we have of one of the reactants, to find out how much of another product or another reactant that we need. But oftentimes, when we start a reaction, we have a certain amount of both reactants or multiple reactants in the reaction, and it's important to understand how much product we can make depending on the amounts of both of those reactants that we're starting with. This type of problem is called a limiting reagent problem, and we'll see why that's the case. So let's use an analogy. Let's imagine that we want to make a cheese omelet. And this cheese omelet is made with 3 eggs and a slice of cheese. And we're going to represent our eggs as SWY for shell, white, yolk, because each egg is made up of 3 parts: a shell, a white part of the egg, and a yolk part of the egg. We're going to treat the white and the yolk together because they're going to stay together and end up in our product, which is the omelet. The cheese is just 1 slice of cheese. So our omelet consists of 1 slice of cheese and 3 egg whites and 3 egg yolks. So 3 WYs. And we're not going to put the shell in our omelet, so we're going to end up with shells left over. And that's a byproduct of our reaction. The product that we're really interested in is this omelet. So let's imagine that we start with our 6 eggs here and 5 slices of cheese, and we want to see how many omelets we can make. And so we can see that if each omelet requires 3 eggs, that with 6 eggs I can make 2 omelets. So this is equivalent to 2 omelets. And so if I want to think about that formally, I can see that the amount that I started with, 6 eggs, divided by the stoichiometric coefficient for doing 1 reaction, producing 1 omelet, is going to give me the equivalent number of omelets that I can make. So we call this the equivalence, and it is the number or number of moles if we're doing chemical reactions that we start with, divided by the stoichiometric coefficient to do 1 reaction or 1 process. So if we think about that in the same way for the cheese, we can see that we have 5 slices of cheese, and it takes 1 slice of cheese to make 1 omelet, and so we can make 5 omelets, or we have 5 equivalents of cheese. Now, if we look at the fact that we can only make 2 omelets, or 2 equivalents, from the amount of eggs that we have, and we can make 5 from the amount of cheese we have, we can see that the amount of eggs is going to limit the total number of omelets that we can make. And so the number of eggs in this case is called the limiting reagent. It has the least number of omelets that we can make. And so it limits the total number of omelets that I can ultimately make. So I calculate the number of equivalents and I look for the least number. And that least number of equivalents is going to be my limiting reagent. And so in this case, I know that my eggs are my limiting reagent because it limits the total amount of omelets I can make. My cheese then is my excess. We call that the excess reagent because I'm going to be left over with extra cheese at the end if I make as many omelets as I possibly can from the 6 eggs that I have. And I can see from my number of equivalents that I will be able to make 2 omelets with my 6 eggs. And so I can see right away that these 6 eggs will make 2 omelets. If I make 2 omelets, I'm going to have 3 equivalents of cheese or 3 slices of cheese left over, so I'm going to have excess. In terms of my byproducts, every egg that I crack creates an eggshell, and so if I make 2 omelets, I'm going to make 6 excess eggshells.